What if there's a fraction involved? What if it's like number 43? The square root of 1 over 121. Now you got two options. Option 1, using your calculator, but you got to know how to do this. In your calculator, and it's going to depend on your calculator, how it does square roots. You could put in the square root of this number, but you got to tell your calculator that this is one single number. If you just put in the square root of 1 divided by 121, it's going to do the square root of 1. It's going to do this step and then divide it. Is that what's going on? No, the whole thing, this is one number. So you've got to tell it it's one number. Or option 2, anytime we see a fraction, square root, well, squaring had to do with multiplying. And multiplying and dividing are joined at the hip. They're undo each other. So square roots also work with, since squares or powers work with multiplying, radicals also work with multiplying. I can break this into two separate multiplying and dividing undo each other. I can break this up. Can you handle those parts individually? What's the square root of 1? 1. What's the square root of 121? 11. You might want to get that list. If anybody got that list of squares handy, you might, yeah, you can't use it on the test, of course, but you might want to be familiar with them because it'll make it a whole lot faster. 0 squared is what? 0. 1 squared is 1. 2 squared? Say 8. I was saying 3 squared is? Oh, I thought you were going to go with 6 there for a minute. 4 squared is 16. 5 is 25. 6 is 36. 7 is 49. 8 is 64. I've run out of room. 9 squared is 81. 10 squared is 100. 11 squared is 121. 12 squared is what? 44. 13 squared is 169. Good, 169. 14 squared is right, 196. 15 squared is 225. 16 squared is right, 256. What happened, man? 17 squared is 289. 18 squared is 325, or 4, excuse me. 19 squared is 361, I think. Somebody check my math. 20 squared is 400. Why do I know that? There ain't no damn reason I know that. It just happens. Probably because I've taught this class like 40 times. You just, some things stick in your brain for no reason. You might need the numbers higher. But at that point, is it worth memorizing more, or is it just put it in your calculator? I would say don't waste your time trying to memorize this, but you might want to have it on a separate piece of paper as a quick reference when you're doing your homework. Because it's going to come back. But while they're copying, anybody notice a pattern here? There is a very definite pattern through your squares. Do you see it? is it?
Go between even and odd.
Yeah, that's more of a convenience than a. Because, well, and because odd times odd is always odd, and even times even is always even, so yeah, it's gonna make sense. But I'm talking about the numbers themselves, how do I get to that value? What would be the next square, the next square number above 400? Did you notice? What's the difference between those two numbers? What's the difference here? Here? And it just keeps going. 33. So from this to this would be 35. Here is 37. This is 39. So what's the next odd number after 39? 41. What's 400 plus 41? Put it in your calculator. It's 21 squared. The next one is by 43. What's 441 plus 43? 484. That's 22 squared. 25 would be the next one. 529. That will be 23 squared. Just a little interesting thing I found about math. Math has got patterns all over the place. And if you take 120 or 111 with me, we look at patterns at the end of class. You know, flowers are all arranged mathematically. The petals on a flower. Do you know the reason why everyone thinks George Clooney is so gorgeous is math? He has the golden ratio.
What's the golden ratio?
The golden ratio is the width, the ratio of the width to the length. And some, for the human eye, some ratios are more attractive than others as far as proportion. And the golden ratio is the one that's the most attractive. And it's like 1 to 1.61 or something like that. It's like the one that most appears most in nature. Take 111 with me. We'll go there. Okay, so what do you do when there's decimals? Like number 45. Keep an eye on the time here. Number 45. What if it's a square root of 0.04? Can you do a decimal? Absolutely. UYC. Use your calculator. Because most of you are going to tell me the wrong answer. Don't do it in your head. Most people are going to say, oh, it's 0.02. No, it's just 0.2. Don't use your head when you're doing square roots of decimals. It's just way too easy to make mistakes. Well, wait a minute, Greg. 2 times 2 is 4. Yes, but remember when you multiply decimals, your answer has to have the same number of decimal places as the two of the numbers combined. So 1 and 1 is 2. 0.2 times 0.2 is 0.04. 0.02 times 0.02 is 0.0004.
What if the calculator doesn't have that?
Go to Dollar Tree and buy yourself a new calculator.
This from Kroger. It was $9.
Well, then you wasted your money. I showed you the one I got, didn't I? I think I showed everybody my $1.25 calculator that does everything plus. Look at this has got sine, cosine, tangent.
From Dollar
Tree.
Dollar Tree.
$1.25. They
They
changed everything. It's not dollars. The only drawback is it is battery powered. So when it dies, go buy another one for $1.25. Seriously? Just make sure the batteries don't run out during a test. So what if there's a number out front, like number 47?
Wait, so that answer is, you said it was 0.2?
Because 0.2 times 0.2 is 0.4 or 0.4. Yeah, for anybody that said it was 0.04, if you multiply that, or 0.02, multiply by that by itself. Not the same number, is it? Just don't try to do decimals in your head. It's just gonna, lead into bad things. So what if there's a number out front? Like 47. -6 square root of 9.
Wouldn't that be multiplication?
What's that?
Is that multiplication?
Yes. One of the nice things about chapter 8 is that you can treat radicals the same way you treated variables. If you saw -6x, that means -6 times x. Agreed? This means the same thing, -6 times the square root of 9. Can you clean this up?
So it would be times 3.
What's the square root of 9? 3. Now, why do you do the square roots before you do the multiplication? If any of you even begin to think PEMDAS, I'm going to throw something at you. Is that a real number? Have you ever seen that number, that on a number line anywhere? 1, 2, square root of 9? No, that's not a real number. This is, again, shorthand. This is where math people are making stuff up because they didn't have, because they're lazy. What does that shorthand represent? 3. That's why we get rid of the radical, because it's not something we can know how to deal with. Now, can you do -6 times 3? Cool. Now, take a look at 53 and 55, or 54 and 56. Which pair do you like? You want the odds or the evens?
What numbers did you say?
53 and 55 versus 54 and 56. You want the odds or the evens?